This is AQA A-Level Chemistry. We're on the Year 12 Kinetics topic. This is video number 5 in this series. In the previous video, we looked at the fundamentals of Maxwell Boltzmann distribution curves. In this video, we're going to look at some of the changes that you might see if conditions are changed within a reaction. So I'm going to recommend you try the activities as you go, and then you get to know what you need to focus your attention on a little more. So in the first instance, we've got a Maxwell Boltzmann distribution curve here, and we're looking at the impact of adding a catalyst. So have a think about the questions on the screen at the moment, and when you're ready, move on to the answers. So I've added the activation energy on. Again, remember that the activation energy must be on the x-axis, which is energy. And from there, we are going to consider that if the area under the curve is the total number of particles, then the area under the curve to the right of the activation energy is the proportion of particles who have energy equal to or greater than activation energy, and therefore whose collisions would result in a reaction. But if I were to write out or draw onto here the activation energy with a catalyst, we know that the catalyst lowers the activation energy. So I'm going to shift it to the left, and you can see my EA cat. And all of a sudden, I've got all of these extra particles who now have energy equal to or greater than the activation energy. So all of these will now have collisions that result in a reaction, whereas previously it was only these that would have done that. So the area under the curve represents the number of particles. Lowering the activation energy with the catalyst means more particles now have energy equal to or greater than the activation energy, and that means there are more successful collisions, so the rate goes up. Now let's consider the impact of changing temperature. And there are 4 questions here to think about that are going to help guide how we're going to draw the amended distribution curves when we change temperature. So, will any particles have zero energy? No. It passes through the origin because no particles have no energy. Will the most probable energy be higher or lower? Remember from the previous video, most probable is the modal energy. Well, actually, the modal energy will be higher. It will be further to the right, because if you have got greater energy, which you get from a higher temperature, that is going to lead to a higher average, whichever average you measure, mode, median or mean. So the peak is going to shift to the right. And will the average energy, the mean energy, be higher or lower? Well, as I've just said, that will also be further to the right. Remember that that is always to the right of the modal energy anyway. Again, the reasons for that were explained in the previous video. Does changing temperature change the total number of reacting particles? No, and that's really important because it means the area under the curve remains unchanged. So let's think about how we can use that information. And you might need to sketch one out like this, but when you have, I then want you to sketch onto that same diagram what the curve would look like at a higher temperature. So at a higher temperature, what do we know? Well, we know that my line is going to pass through the origin because no particles have no energy. But actually, we also know that the peak is going to shift to the right. We'll deal with most probable energy. Now, it is going to shift to the right, but it's also going to shift down. And we need to think about why. If the area remains the same and more particles have higher energy, then we're essentially stretching this curve across. We're pulling it over. So more particles have higher energy. So we can't possibly have the same number with the probable energy. Now, the other important thing to watch out for here, it will only cross the original curve once. We can see that here. It cannot meet again further over. So it must never meet again. It leaves from the origin together, they cross once, and they never meet again. So what would you do if we were going to a lower temperature? Have a think about this one. In this case, we have got a lower most probable energy because overall the particles have less energy, because less thermal energy from a lower temperature means less kinetic energy. Now that means the peak will move to the left and it will move higher. So your sketch goes from the origin, it goes up, it crosses once, it comes down below, and it must not touch either the x-axis or the other curve again. And these are the most common sketches that you will need to do within your exam, where you'll be provided with a Maxwell Boltzmann curve and you must add your own curve over the top of it. That takes us to the end of this video. Thank you for listening and goodbye.